Hello friends, welcome back to our channel Abhi Chemistry Tutorial. So in this video we are going to learn a new topic, oxymercuration. So already we are learning the organic naming reaction series and this is also one among that. And if you have not checked the other videos in the organic naming reaction series, I have given the links of the playlist in the description box. Kindly check the playlist, and this PowerPoint slide presentation is a new attempt for me, and already you might have seen I have tried with my handwritten notes and whiteboard, blackboard, everything. So kindly tell me whether you like this video or not in the comment section, and please don't forget to subscribe to our channel because I am doing every video with a lot of hard work. So please subscribe to our channel, and every subscribe you do will boost me up to do more and more good videos so that you can also learn a lot from Abhi Chemistry Tutorial. So now let's get started. Oxymercuration. So what is oxymercuration? It is an electrophilic addition reaction. Okay, so it's an electrophilic addition reaction that transforms an alkene to an alcohol. So what is an alkene? A compound with a double bond. So the alkene is transformed into an alcohol. That is, this will gain an OH group. So this is the oxymercuration reaction. So why the name becomes oxymercuration? So alkene reacts with mercuric acetate. So that is the reason we say it as mercuration reaction, oxymercuration reaction. So in the aqueous solution, to yield the addition of acetoxymercury group and hydroxyl group across the double bond. So you know this is an alkene group, that is it will have a double bond, and one of the acetoxy group and a hydroxyl group will be attached on either side of this double bond. So this addition of this OH group will follow Markovnikov's rule. So already you might have studied Markovnikov's rule. So here I will remind you what is Markovnikov's rule. The hydroxyl group, when it adds to an alkene, the OH group will be substituted to the more substituted carbon. For example, if you have a carbon CH2 and CH with the substitution of methyl here, if we have to attach a OH group to this molecule, this OH group will attack the more highly substituted carbon, that is CH group. So this is the Markovnikov's addition, and the two groups that attach the two side of the double bond will attack at the anti position. That is, the higher priority groups will be in the opposite direction, that is trans to each other. So this is called oxymercuration. Oxymercuration followed by demercuration is called oxymercuration reduction reaction. So I'll explain with an example. So this is 1-methyl cyclohexene. This is treated with mercuric acetate and water and diethyl ether. So we will get the addition of mercuric acetate in this bond, and so it is called oxymercuration. And the next step is the addition of sodium borohydrate. So usually when we add sodium borohydrate, what will happen? Removal of hydrogen will occur. But instead of hydrogen, here the removal of mercury occurs. So here you can see in this reaction, when it is subjected to sodium borohydrate and sodium hydroxide, we will get the compound without mercury. The mercury will be the byproduct in this reaction. So the reaction, in this reaction, addition of mercury and also removal of mercury takes place, and that's the reason we say it is oxymercuration reduction reaction, or it is also named as oxymercuration reaction. Next we will learn about the mechanism. The mechanism occurs in 3 steps. So the step 1. So in the first step, the nucleophilic double bond attacks the mercury ion, ejecting an acetoxy group. So the double bond is rich in electron, and that's why it is called nucleophilic, nucleus loving. That is, the nucleus will have positive charge and it attracts the negative charge. So the double bond is electron rich. That is why we say it is nucleophilic double bond, and this double bond will attack the mercury ion of the mercuric acetate. So the second point I'll explain with this reaction. So here you can see the mercuric acetate and also the alkene here. And this acetoxy group will be removed and this mercury will gain a positive charge. So that is what given here. The electron pair on the mercury ion attacks the carbon on the double bond. How it attacks? So this double bond will have two bonds, right? So one bond will have two electrons. So these two electrons will pair up with the two electrons of this mercury atom and will form two bonds with the mercury atom. So this is what represented here. And since the electrons are deficient in this mercury, it will gain a positive charge. So this is the step 1. So step 2. So step 2 is the addition of water molecule. That is, the water molecule acts as the nucleophile. So we say that the nucleophilic addition of water molecule takes place. So here you can see the water molecule is attacking the carbon which is more substituted. That is, which is highly substituted carbon. And since this pair of electron from water is donated to this carbon atom, it will form a bond here. And this carbon will give the two electrons of this bond to mercury back. And this mercury will be neutralized and this positive charge is removed and this only this bond will sustain in this final product. That is, this is also an intermediate, and this oxygen, since it has lost its electron pair, will gain a positive charge. Step 3. So the step 3, the acetoxy ion which was already expelled in the first step now attacks the intermediate that we got in the
Step 2.
and also abstracts a proton from the intermediate to form acetic acid, and it will give the product alcohol. So see this reaction, the acetoxy group which was removed in the first step now attacks this intermediate that we got in the second step, and this will attack the hydrogen and it will remove an hydrogen as H+. So I'll explain here. CH, O, hydrogen, hydrogen. And now acetoxy group is here and this H will be removed as H+. And this will become CH3COOH, acetic acid. And now this bond will shift over this oxygen so that the positive charge over this oxygen will be neutralized, and so we will get CHOH as the final product, and that is what explained in the second step. So the two electrons participating in the bond between oxygen and the attacked hydrogen. Okay, so the bond between the oxygen and the attacked hydrogen, the electrons will collapse or shift towards this oxygen, and this is what that will create the final product alcohol, the neutral alcohol as the product. So this is the product. So this is all about oxymercuration. So I hope the video is useful for you. So please like the video, share to your friends, and don't forget to subscribe to our channel. See you all in the next video. Until then, bye. Thank you.